Good morning, ma'am.
Good morning.
Good morning.
Good morning, ma'am.
Good morning. Mitushana, you are in this group, right?
No, Miss. Medushana and Samina group 2.
Both are in same group. Okay. So we'll wait few more minutes to start. Here, so please share your notes with them and give the instruction about the practical record book as well. Can you see my screen?
Yes, ma'am.
Yes, ma'am. Yes. So today's practical is practical number 4 and stream flow measurements. So in today's practical, we will discuss about what is stream flow and how to calculate stream flow.
Recording in progress.
What are the methods used to calculate stream flow and the procedure. So what is stream flow? What do you mean by stream flow? Anyone? Here you can see this is a stream. So what is meant by stream flow?
It's the current flow of water.
Yes, the amount of water flow through that stream is stream flow. So stream flow or channel runoff is the flow of water in streams, rivers and other channels. It is a major element of the water cycle. Stream flow is the only part of the hydrologic cycle that can be measured accurately. Rather than precipitation and interception, this stream flow we can measure it accurately. Stream flow is measured as volume of water passing through a specific point over time. So at a particular time, what is the volume of water is passing the stream. It's called stream flow. So the unit of that stream flow is meter cube per second. The meter cube is volume. Second is time. So over a time, what is the volume of water passing through the specific point? The streams are developed from the contribution of the overland flow and interflow from the catchment with groundwater contribution and channel precipitation. It means what are the ways that stream get water? So what are the ways? Directly from the precipitation. Here this is your land and from the precipitation this land get water and the thing this is a stream. So this stream also directly get water from the precipitation and once the precipitation reaches the land it will go inside. The last lectures we studied about this infiltration. So the water infiltrate and again passing through and meet the groundwater. So this groundwater also mixed with this stream, groundwater. And the water infiltrate and moves horizontally. It is called seepage. So this seepage water also mixed with these streams and rivers. And another way is the runoff water. The surface runoff water also mixed with these streams and oceans. So this is how these streams get water. So what do you think? Why the measurement of stream flow is important? Why it's important? Especially to predict the flood. Sometimes if continuous precipitations, the streams and rivers get more water. At that time, flood may happen. So the continuous measurement of stream flow is important to predict the flood. And also planning for the optimum utilization of the water resource. If we take in our country, mostly the northern part of our country, the people get water from the well. So this well water is used for their drinking purposes and the irrigation purposes. But in the southern part, mostly the people use rivers and stream water. So that stream and river water used for their drinking purposes and also for the irrigation purpose. So this stream flow is important. So at a time, how much water is flowed through the stream is important to calculate how much water they can distribute to the people at a particular time. For this planning purposes, the stream flow is important. Categorization of stream flow measurements. Stream flow techniques are broadly classified into two categories. First one is direct determination of discharge and the second one is indirect determination of discharge. Under the direct determination of discharge, there are so many methods used. Area velocity method, dilution techniques, electromagnetic method and ultrasonic method. These four methods are direct determination of discharge method. And the indirect determination of discharge methods are slope area method and hydraulic structures. So in today's practical, we will mainly consider about this area velocity method. So what is the difference between this direct determination and indirect determination? The indirect determination is we have to construct something to take measurement. Some special structures we need to construct and take the measurements. But the direct determination method, no need to construct those special constructions. Just we have to measure the velocity and area, we can get the discharge. So that is direct determination. So we'll discuss the theory beyond this technique. The most common and direct method for the determination of discharge in reverse is the velocity area method. The area velocity method or velocity area method, both are same. So this method determines discharge from the product of average stream velocity and the channel cross-sectional area. So earlier we discussed that what is the unit for the discharge is meter cube per second. So we can't directly get the volume. So how can we get the volume? With the area and the depth of a stream. So the discharge is calculated with cross-sectional area into average velocity. What is the unit for this cross-sectional area? Is meter squared. Average velocity is meter per second. So meter squared into meter per second is meter cube per second. So that's how we can calculate this discharge. of your stream. What do you think? The velocity is equal for every way of the channel, or it's different from point to point? What do you think?
Different from point.
Yes, it's different from point to point. Stream velocity is typically faster at the surface and towards the middle of the channel. So, the stream velocity is very high on the surface part and particularly from side to middle part. It's very high at the middle point. And it's slower along the sides and the bottom of the channel due to the differences in friction. So the velocity is very high in the surface rather than the bottom part. And in the surface area also, it's very high in the middle portion. And it's going to slow down in the side portions. The average velocity is usually at 0.6 times the total depth from the water surface, or 0.4 times the total depth from the bottom of the channel. So we need to calculate the stream discharge. We need to measure the average velocity. For that, here you can see the velocity at this point is 1.9 meter per second. Here it's 1.7, 1.5, 1.3. Likewise, it's decreasing. So how can we get an average value for a point? If you take this portion, then how can you get the average one? So normally we consider the average velocity is usually at 0.6 times the total depth from the water surface. From the top, the 0.6. If it's 1 meter, the 0.6 is 60 centimeter from the surface. Or in other words, 40 centimeter from the bottom. So at that 60 centimeter from the surface, at that point, we can take it as an average velocity for this depth. So that's how for this depth, we need to measure the depth and take the 0.6 times from the surface and take the value as an average value of that depth.
Ma'am, can you explain?
Yes. Yes, sure. So once you take this stream, the depth is different from point to point. Here the depth is this much. Here the depth is this much. In the side area the depth is very less. So according to this law, the velocity is different from point to point. So we need to cut down this stream into so many portions to take the velocity according to the depth. And for this depth, we need to take average velocity here. For this depth, we need to take average velocity from here. Likewise, we need to divide it and take the average value. But in another case, the velocity is different from point to point in this portion also. So, in the surface area, the velocity is high. Once you go down, the velocity decreases. So, for the discharge calculation, we need to take area of that portion and the average velocity. So, with this measurement, we can take the area. But velocity is different from point to point. Then how can we get the average velocity? For that, according to this velocity values, normally once we take the value from the 0.6 time from the surface, it will give the average value for this hole. Just think, it's 1.9, it's 1.3. So what's the average value for these two? .2 divided by 2 is nearly 1.6. So that average value is 1.6. Here, where is 1.6 is located? Somewhere here, right? In between this 1.7 and 1.6. That 1.6 is not in the center portion. It's somewhere 0.6 times from the surface. So, for that, rather than taking so many values for velocity, we can take 0.6 times, we can measure the total depth and calculate how much distance from the top is 0.6 times. Then calculate the depth and we have to take the velocity value at that point and we can take it as an average velocity. Can you get my point?
Yes, ma'am. Thank you.
Okay. So this is the velocity variation along the cross section of the channel. Here, this is the stream bottom and this is the surface of the stream. At the surface area, the velocity is very high. Your x-axis is velocity in meter per second and your y-axis is distance below water surface in percentage of stream depth. Once you draw a graph, you must point out what is your x-axis and y-axis. So the velocity is very high on the surface area and it's very less in the bottom part. So this is how the velocity is changing from the depth. velocity of the channel flows varies approximately as a parabola from zero at the channel bottom to the maximum near surface as shown in the figure. This shape is called as parabola shape. So the velocity of the channel varies approximately as parabola from zero at the channel bottom. Nearly the bottom velocity is nearly zero and the maximum near the surface. Since the velocity of the flow varies across the channel, the measurement has to make in several spots in a cross section. If depth of water is shallow, one measurement is enough. Sometimes your stream is something like this. And there is a possibility your stream is like this. So here the depth is very less. This type of stream we can call as shallow depth stream. Here the depth is very deep. So we can call it as deep stream. So if the water is shallow, one measurement is enough. So if we divide this shallow stream into many portions, particularly for this portion, one measurement is enough. So at that time, one measurement from where earlier we discussed 6/10 of the total depth below the surface. So 0.6 times the depth from the surface. We can take 0.6 d from the top. If the depth of the water is deep, at 210 and 810 depth below the surface on the same vertical line gives the average velocity. So this time your depth is very large. If you need to increase the accuracy, you need to take at least 2 measurements. So in this case, no, you don't take this 0.6d depth. At this time, you need to take 0.2d depth from the top and 0.8d depth from the top. So for the deep stream, 210 and 810 depth from the surface. And the shallow stream, 0.6d depth from the surface. So for these two types, you need to consider if it's shallow or deep. The shallow water is nearly the depth is less than 2 feet. 2 feet is 1 feet is nearly 0.32 meters or 0.3 meters. So 2 feet is 0.6 meter, nearly 60 centimeter. If the depth of your stream is below than 60 centimeter, you consider it as a shallow stream. If the depth is more than 60 centimeter, it's deep stream. Here you can see this is the shallow depth. The depth is nearly his foot level. So at this time, only one measurement is enough. But here you can see this is the deep depth shallow. So for this case, you need to take two velocity at a point. So this is the 0.2 into the total depth. Here it's the 0.8 into the total depth. The middle of the channel, the depth is high, but the side channels, that is very low. So for these both sides, one measurement is enough. For that one measurement is 0.6 into the total depth. For the side 0.6, but in the middle, the two measurements, those are should be 0.2 and 0.8 into the total depth. So there are two types of techniques used, direct and indirect method. Under the direct method, there are so many methods. We will discuss about this area velocity method. This method of discharge measurement consists essentially of the area of cross-section of the river at a selected section called the gorging site and measuring the velocity of flow through the cross-sectional area. So before we start the practical, we need to select a suitable place. This is not only for this stream flow measurement, for each and every practical like precipitation measurements and interception measurement, everything first we need to select a suitable place. So that here in the stream flow, the suitable site is called gorging site. And the measuring the velocity of the flows through the cross-sectional area. So before selecting a place, we need to consider so many things. First one, the stream, sorry, the stream should have a well-defined cross-section which does not change in various seasons. So there are streams only flow during the wet season. Wet season means during the wet season, precipitation is high. So only that time that river is flowing. Other time it's dried up. So for this measurement, we need to select a stream or river. It's flowing all through the year. So the stream should have well-defined cross-section which does not change in various seasons. The next is it should be easily accessible all through the year. So why it's easily accessible? to the stream flow measurements, we need to take some equipments to take the readings. So we need to carry something with us. So if a site is easily accessible, it's easy for us to conduct the practical. Otherwise, it's very difficult. So it should be easily accessible all through the year. And next one is the site should be in straight, stable range. So sometimes the rivers not in a straight way, it's going here and there, not a straight line. So we need to select a straight site. Next one, the gorging site should be free from backwater effect in the channel. What's the backwater effect? Sometimes in your river, there are some barriers, means some rocks or something is in the middle of your channel. So at that time, what will happen? The flow is here, the water is touch this barrier and coming again. If it's touched and come again, then go. So likewise, the flow is not a uniform one. So this time, this is called that backflow, backwater effect. So we need to select a site. It should be free from this backwater effect. So we have to consider all these things before to select a gorging site. So now we'll move to the procedure of the area velocity method. So for the first step is, we already discussed that, select the suitable location along the channel. As area to be accessible always, monitored and should be a stable stream channel or at least not significant alteration. So it's a stable one. Then measure the horizontal distance. It means the width of the channel from reference point on shore to the point where the water meets the shore in other side by steel tape. So we have to select a site, then measure the total horizontal distance of the channel by using the steel tape. To calculate the discharge, what are the parameters do we need to measure? Area and the velocity. In area, we need to measure the horizontal distance, this width, and what is the next parameter to calculate the area of this channel? What is the next parameter? First one is width. Second one is tell me.
Depth.
Yes, good. Depth. So here we measure the width. Then we need to measure the depth. With the width and depth, we can calculate the area. And the next parameter is velocity. Once we measure all these things, we can calculate the discharge of this channel. Then subdivide the cross section of the channel into small subsections, rectangular grids, based on the shape of the channel or river. So why we are going to subdivide this section? Because velocity is changed from middle to side section. So we can't get one velocity value. That's why we have to subdivide the cross section. No section should include more than 10 to 20% of the total discharge. In the middle section, the velocity is very high. So at that time, what will happen? Water is moving very fast. So for a particular time, the amount of water moving through the center point is very high. So we need to divide the center portion into very small rather than the side section. Here you can see in the side area, the width is higher than the center portion. In the side area, the depth is very small and the velocity also very less. So the amount of water passing through a second is very less compared with the middle portion. So we have to subdivide the section, and no section should include more than 10 to 20% of the total discharge. That's why we have to divide the center portion very less weight. Then determine the area of each section by directly measuring its width and depth. Measure the depth of the channel by rod and take the width by steel tape measurement. First, we have to measure the total width. Then, according to that width, we can plan how many portions we have to divide. Then, we have to measure the width of the subsections and the width. So taking width is very easy because in the surface we can use this measuring tape and take the reading. But the taking the depth is little bit difficult. For that we are using that rod. So which type of rod? So this is a rod. Here the measurements are here. 0 is starting in the bottom part. 0, 1, 2, 3, 4, likewise. So once we immerse this rod here, so it's 0 is here. So we can directly take the surface depth using this rod. Estimate the areas as follows. here side, both of the shore may be triangle. Sometimes we can divide the channel like this. So at that time, here you can see the side portions are in triangle shape. With a sharp triangle, we can use, how can we calculate the area of a triangle? Half into base width into vertical height. So at that time, if it's a sharp triangle, we can use this 4 to calculate the area of these sides. And the middle portion is normally it's a rectangular grid. So you can calculate the area with the vertical height and the base width. If your stream is like this, then you can divide it like this. So this time, this shape is not a triangle. So this type, you can take it as a rectangular grid. So at this time, no need to use that rectangular calculation for these sides. So you can consider the whole as a rectangular grids and calculate. If it's a sharp triangle only, you can consider. Otherwise, no problem. So area calculation, we finished. Then we need to calculate the velocity. So take the revolution reading from the current meter and determine the average velocity. The current meter is used to measure the velocity. So if we insert the current meter in a particular depth, and it will give the revolution reading. So per second, how many times it rotates. The revolution per second is displayed there. So there is already a standard equation is there. So you can directly use that revolution number and get the velocity value. So this is how this current meter works. So area you already calculated and the velocity also now you can get. So finally you can multiply these two and get the discharge. Make sure that the current meter is kept as vertical. If shallow depth of water, current meter to be attached to a wading rod or can be used directly. If fast or deep water, to be mounted just above a weight suspended from a cable and use the system. If your stream is very shallow, then you can directly insert because the depth is very low, so you can insert your current meter by your own. But if the depth is very high, you need to tie up your current meter with a rod and insert it. So this is the procedure using in the area velocity method. So it's easy. First one, you have to select a suitable site. Then measure the total width. According to the width, you need to divide your channel into the subsections and measure the width and depth of each subsections and calculate the area. Then using current meter, you can take the velocity at each point, then calculate the total discharge. current meter. See, this is the current meter and this is the rod. For the accurate determination of velocity in a stream, we have a mechanical device known as current meter. It is the most commonly used instrument to measure the velocity at a point in the flow cross section. So, you know what is the point measurement? So, if you insert in a particular depth, it will give the velocity at that particular depth. That is called point measurement. Current meter has a wheel of 6 conical cups. In the front portion here, you can see the 6 conical cups that revolve around a vertical axis. An electronic signal is transmitted by meter on each revolution to be counted and timed. If these cups are rotating according to the moving of water, the signal is transmitted through this and it will display in the meter. So it will give at a particular time how many times these conical cups are rotating. Because the rate at which the cups revolve is directly related to the velocity of water. Here stream is moving in this side. Here you insert your current meter. The cups are here. So if the speed of this stream is very high, what will happen? The cups will move very fast. So the number of rotations per second is very high. If the velocity is very less, if the velocity is high, the number of revolution per second is very high. It will rotate very fast. If the velocity of the water is less, what will happen? The number of rotation per second will be very low. So the velocity is proportionate to the number of rotations. If it's high, the number of rotation also high. If it's low, the number of rotations also low. So the velocity of the water is directly proportionate to the number of revolutions. Here this is the sounding weight. If your stream is shallow stream, No need to add this weight. Why? If it's a shallow one, depth is very low, you can directly insert this current meter. But if the depth is very high, if you insert this current meter without this weight, what will happen? This current meter tries to float. It will move upward automatically. To avoid this, you need to insert this sounding weight. This fin, the shape of this fin is used for the stabilization purpose. The typical relationship is used. So this is the equation which is used to calculate the velocity. From the current meter, we can get the number of revolution per second. So this is a standard equation for a particular current meter. So current meter to current meter, this A and B values are vary. So V is equal to A. A is the constant into number of revolution per second plus B. B also constant. So each current meter, these A and B values are different. So once you use a current meter, you can substitute that A and B values, and with the measurement you can get the number of revolution per second, and you can substitute all these things and get the velocity of that point. So likewise, each point you have to insert it and calculate the velocity and get the average velocity of that subsections. Calibration method. Need to find out the relation between the stream velocity and revolutions per second of the meters, which is nothing but the calibration equation. The calibration equation is unique to each instrument. So what is calibration? We need to get the relationship between the velocity and number of revolution. With this calibration method, they have get this type of equation. By using the calibration method, and they have to calculate what is the A and B values. According to this, they have to give this type of equation. To get this type of equation, this calibration method is used. So the calibration equation is unique to each instrument. The current meter producers, for each instrument, they have to use this method separately and get the A and B values. It is determined by towing the instrument in a special tank. A towing tank is a long channel containing still water. Still water means not a moving water. It's a still water, not moved water, with arrangements for moving a carriage longitudinally over its surface at constant speed. So for this case, the water is not moved, but the current meter attached with the carriage is moving. So they have to attach a motor with the carriage. It will show a constant speed. So it will show what is the speed the carriage is moving. With the current meter, we can get the number of revolution per second. So with a particular speed, we can get what is the number of revolution. According to these two, they can develop a graph. With the graph, they can get the A and B values. Current meter is moving, not the water. But in a stream flow, current meter is not moving, but the water is moving. The instrument to be calibrated is mounted on the carriage with the rotating element immersed to a specified depth in the water body in the tank. We already discussed this. The carriage is then towed at a predetermined constant speed and the corresponding average value of revolution per second is determined. See, this is the longitudinal channel. The water is not moving, and this is the carriage. Here, he will insert the current meter at a particular depth. So this carriage will move with a constant known speed, and he can get the number of revolution per second in the display that he has. According to this, they can develop that constant. Before going to the calculation, I will show a video. Can you see my screen?
Yes, ma'am. Yes, ma'am.
Uh,
Yes, ma'am.
Yes. So see, this is the current meter, and now he is attaching the current meter with that measuring rod. This is the rod. Here, the zero is starting from the bottom. Once he attached the current meter, now he's attached the cables. So this cable is used to pass the signal from how many revolution per second, and the other end is joined with that display cable. Here, the number of revolution is displayed here. So he already select the gauging side. Then he will measure the total width of this channel. He already attached two rods here and tied his meter tape permanently here. Why? He fixed his measuring tape here? Because once he measure the total width, he need to divide this channel as subsections. So once he decided to divide the channel into equal 2 meter space, once this measuring tape is there, it's easy to identify what is the 2 meter from the starting point. Then what is the next 2 meter from the starting point. So if he fixed it permanently, it's easy to him to identify the width. So the next thing is, with the measuring rod, he will measure the total width, and he need, according to the, what is the depth he need to insert for the shallow, 0.6 meter from the surface. So first he measure the total depth of the channel and refix the current meter to the 0.6 meter and insert the current meter at the particular depth and take the measurements. Likewise, for each 2 meter depth, he will take 2 measurements. he use the calculation to what is the depth he need to fix. Here, the measurement is there, so it's easy to him to fix at a particular depth. After that, insert the current meter and get the reading here. So is that clear? Is that clear?
Yes, ma'am. Yes, ma'am.
Yeah, okay. Now we will move to the calculation part. Estimate the flow in a stream from the measurement with the current meter. First, you have to sketch down this one. From the horizontal scale, you can identify the width of each section. So can you please tell what is the width of this section 1? What is the width of this section 1?
Meter.
2 meters. Yes. What is the width of this section 4?
1 meter.
1 meter. So for the section 1, it's 2 meter. Section 2, 1 meter. Section 3, 1 meter. Section 4, 5, 6. All are 1 meter. And the section 7 is 2 meters. Yes. With the picture, you know the width of this channel. And then you have to identify the depth of the channel. So here, for the section 1, you can take the average depth nearly in the center point. So, roughly wait, I will show you. The depth of that section 1 is nearly 1.3 meters. Please write down the section 1 depth is nearly 1.3 meter. The depth of section 2 is 1.7 meter. We are going to take the average depth. That's why I'll take the center point reading. The depth of section 3 is 2 meter. Depth of section 4 is 2.2 meters. Section 5 1.8 meter. Section 6 1.4 meters. Section 7 0.7 meter. So now you know the width and depth of each section. With that you can calculate the area, and they will give the velocity at, for the side 2 portions, the velocity at 0.6 depth, and the middle portion 0.2 depth, and here 0.8 depth. So for this middle portion, you have to take the average velocity, and for the side 2 portions, you can directly use this velocity. So if you draw a table like this, it's easy to calculate. Here, first you have to write down the section. Then flow velocity 0.2d and 0.8d. For the two side portions, they don't give the 0.2 and 0.8d. They will give the 0.6d. So you can directly put the velocity in the mean column. For the other section, how to calculate the mean? 0.8 plus 0.6 divided by 2 is 0.7. Here 0.9 plus 0.6 divided by 2 is 0.75. Likewise, you have to calculate the mean values. Then depth you already know, width you already know. And how to calculate the area? Depth and width. 1.3 into 2 meter is 2.6 meter square. 1.7 into 1 meter, 1.7 meter square. Likewise, you have to calculate the area's value. Then, how to calculate this flow or discharge? Is area into mean velocity. So, 0.5 into 2.6 is 1.3. 0.7 into 1.7 is 1.19. You have to put the units in the top column. Otherwise, you have to write down in each place. So, better to put in the top column. Then, how to calculate the total discharge? Here, this is the discharge from the first section. This is the discharge from the second section. The full stream is contain all these 7 sections. So your total discharges, you have to add your discharge from each section and get the total discharge is, and in the finally you have to give the total discharge from the cross section of the channel is 9.23 meter cube per second. So likewise, you have to do your calculation. Is that clear?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. Shall I move to the next question? Okay. Now, the second example. The rating equation for the current meter is V is equal to 0.51 ns. ns is revolution per second plus 0.003 meter per second, where ns is the revolution per second. calculate the discharge in the stream. So this is the real situation. From the current meter, you can get the NS value. So how can you calculate your velocity? So you have to substitute this 0.39 here and calculate the velocity for this portion. So likewise, separately, you have to substitute each value and get the velocity value. So in this case, they will give only one value for each section. So why? Maybe it's a shallow stream. So only one value is enough to take it as an average value. Here they directly give the width and depth. So you can calculate the area with these two. Then with the number of revolutions, you can calculate the velocity. And velocity into area, you can get discharge. So likewise, you can calculate your discharge. So at last, you have to give the total discharge from the channel is 6.454 meter cube per second. up to this point is enough for you. This is the area velocity method. For your additional information, I will give this dilution method. So no need to write these things in your practical record book. Clear? Don't write. For your additional information, I will give this one. So I quickly go through this. In the direct method, there are area velocity method. We discuss those things. The second one is dilution method. The salt dilution method involves injecting a known amount of salt into a stream. This process is technically known as slug injection. Here, they will inject chemicals. So the salt acts as a tracer to measure the discharge. The concentration of dissolved salt is measured downstream at a point where it has fully mixed with the stream water. Here, sometimes the salt is colorless. So, for the easy to identify, they will mix some kind of dyes or colors. So, at a point, they will inject with the known concentration. And after some point, they will again measure the concentration. With the concentration and the velocity, they will calculate the discharge. With using this kind of method, the chemical should be non-toxic and not to be very expensive. Should be capable of being detected even at a very small concentration. If we mix in a high concentration, it will toxic for you. So you can't use that stream water for drinking purposes or irrigation purposes. So you should be very careful to how to get a non-toxic chemical to use for this dilution method and should not get absorbed by the sediment or vegetation. If the vegetations or the plants, they absorb the chemical, it's toxic for them and it should be lost by evaporation. If it's lost by evaporation, then the chemical concentration will be low in the stream. So you have to select a chemical which has all these qualities. The next method is ultrasonic method. It's essentially an area velocity method, but the average velocity is only measured using ultrasonic signal. In the area velocity method, we use current meter to measure the velocity, but in the ultrasonic method, they use ultrasonic signals to measure the velocity. And then in the indirect method, there are flow measuring structures and slope area method are there. So what is the flow measuring structures? Structures like notches, weirs, flumes and sluice gauge for flow measurements in hydraulic laboratories are well known. These conventional structures are used in the field condition, but their use is limited by the ranges of head, debris or sediment load of the stream and the backwater effect produced by the sea. So here you can see this is the sluice gate. Here this is the weirs and this is the V-notch. So this type of special structures are inserted in the way of the stream. So in the side, the measuring tape is fixed. So they can get the height of the water is flowing through these weirs or V-notches, and they already developed some equations. So they can put the height of the water which is flowing through this channel, and with the help of that equation, they can get the stream flow. So these are the structures. This is the indirect method. So if the flow water have some debris, sometimes its sediments are here. they block the flow of the channel. So it will not give the accurate flow. So these are the backdraw of these types of methods. So today we will discuss the stream flow measurement. There are two methods, direct method and indirect method. Under the direct method, there are so many methods we have used, mainly area velocity method using current meter we discussed today. So what is the procedure of this area velocity method? First, you have to select a site. Then measure the total width using measuring tape. With the total width, we have to plan how many portions we have to divide. Then subdivide the total width into small sections. Then measure the area of each section. How to measure the area? By using the width and depth of that small section. Then take the current meter readings and calculate the velocity. So finally, calculate the total discharge by velocity and the area. So likewise, you can get the total discharge value. So is that clear? Do you have any clarification according to this practical? You have to speak. Purni, is that clear?
Yes, ma'am.
Yes. Any others? Yes? So what do you mean? I can't get your question. Yes? Wait. So for today's practical, you have to write the introduction part and the theory. Then the area velocity method and the procedure. Then the current meet this question. Up to that question you have to write. Right? No need to write this dilution part. Okay? Up to that calculation you have to write. Okay. So we have few more minutes. So shall we discuss that infiltration portion? We need to cover two more slides. Shall we?
Yes, ma'am.
Okay.
Yes. Yes. So on the Monday lectures, we will discuss interceptions and infiltration. In the infiltration, we talk about what are the factors affecting the infiltration capacity. The first one, precipitation. Then soil characteristic, soil moisture content and organic materials in soil. Up to this one, we finished. Now, we will discuss how this land cover affect the infiltration. If the land is covered by impermeable surface means a surface, this is your land portion, land or soil portion. This impermeable portion is above your land. So this portion do not allow water to passing that layer. If the precipitation is here, once the impermeable layer is here, the water can't passing through this layer. So the water can't arrive the soil. So this impermeable layer is in between the precipitation and the soil. So it can't allow for the infiltration. If the land is covered by impermeable surface such as pavement means the cement layer which is used for your walking purposes. So that cement portion, it will not allow water to move further inside. So infiltration cannot occur as the water cannot infiltrate through an impermeable surface. Vegetation cover of the land also impact the infiltration capacity. What will happen if your land is fully covered with these trees, bushes? Most of the water will lose through the interception. So this vegetation capture the water as interception and losing through the evaporation. So the amount of water which reach the land is very less. So if the vegetation cover is very high, the infiltration is very low. The vegetation cover of the land also impact the infiltration capacity. Vegetation cover can lead more interception of precipitation, which can decrease the intensity, leading to less runoff and more interception. Not only the infiltration is affected, the runoff also affects. Why? These plants capture most of the precipitation as interception. Increased abundance of vegetation also lead to higher levels of evapotranspiration, the transpiration losses, which can decrease the amount of infiltration rate. So this is how this land cover affect the infiltration. The next factor is slope. When the slope of land is higher, runoff occurs more readily, which leads to low infiltration rates. The thing. So your land may be floodland or slopy land. If it's a floodland, once the precipitation reaches, what will happen? Once it reaches the land, it comes down as infiltration. So once if its loss as runoff is very less, because once these pores are saturated, then only it started to move as runoff. But in this type of case, if it's a steep slope, what will happen if the precipitation is here? There is a fraction of second needs to water to get into the soil. So in between that time, it's easily waste as a runoff because the land is very slopey land, very steep. So at that time, the runoff loss is very high. So this slope also affect the infiltration rate. So this is what I want to share with you. So this is the infiltration portion. So that's all for today. If you have any doubt, you can clarify, or else you can leave the class. Thank you. Have a great day.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you.